Ever wonder how your phone recognizes your voice or how AI spots a cat in a photo? The secret is something called a tensor. Tensors are just super organized containers for numbers. Think of them as the backbone of how computers understand the world. They translate everything, photos, music, text, into numbers, making AI possible. By understanding tensors, you get a backstage pass to the magic of modern technology. Let's start simple and build up. From a single number to the multi-dimensional world of tensors. Let's begin with a single number, like the temperature outside, 25 degrees. In tensor terms, that's a scalar, a zero-dimensional data point. Now imagine tracking temperatures for a week. That's a list, a vector or a one-dimensional tensor. Need more structure? Think of a chessboard, rows and columns. That's a matrix, a two-dimensional tensor. Spreadsheets, black and white images, these are all matrices. But what if you want to store a color video? You need height, width, color channels, and time, multiple dimensions. That's where tensors shine. They're containers that can have any number of dimensions. Scalars, vectors, matrices, they're all just special cases of tensors. Tensors let us represent everything from a single price to a full-length movie in a unified way. This flexibility is why they're the foundation of AI and data science. Ready to see how dimensions work? Let's break it down. Tensors are defined by their rank, the number of dimensions they have. A scalar is rank 0, just a single number. A vector is rank 1, a list like 10, 20, 30. A matrix is rank 2, a grid, like a spreadsheet or a grayscale image. Add another dimension, say color channels, and you get a rank 3 tensor, perfect for color images. Videos? That's rank 4 height, width, color, and time. The rank tells us how many directions we can move to access data. This structure lets us handle everything from simple stats to complex, multi-dimensional data. The higher the rank, the richer the data we can represent. Now let's see how tensors power real-world AI. Tensors are everywhere in AI. Take images. A grayscale photo is a matrix, a rank 2 tensor. Each cell is a pixel's brightness. Color images? They're rank 3 tensors, height, width, and color channels, red, green, blue. AI models process these tensors to spot edges, shapes, and objects. In deep learning, data flows through layers as tensors, transforming at each step. Each layer multiplies the input tensor by learned weights, creating new tensors and new representations. This is how neural networks see and make predictions. In language, we turn words into vectors, rank 1 tensors, using embeddings. Sentences become matrices, where each row is a word's vector. This lets AI analyze meaning, grammar, and sentiment, all with tensors. Whether it's pixels or paragraphs, tensors are the math behind the magic. Tensors aren't just for storing data. They make deep learning possible. In forward propagation, input tensors flow through network layers, transforming from raw data to features to predictions. Specialized hardware like GPUs can process these tensor operations at lightning speed. The network's final output is often a simple tensor, a vector of probabilities. Learning happens through backpropagation. The network compares its prediction to the correct answer, calculates the error, and sends it backward as a tensor. This error tensor guides how the network's weights should change. Tensors make it possible to update millions of weights at once thanks to their structure. Their multidimensional nature lets us handle images, video, and more, all in one framework. Without tensors, deep learning would be slow and clunky. They're the universal language that powers AI's rapid progress. Tensors aren't just for AI, they're essential in science and engineering. Einstein used tensors to describe how gravity bends space and time in general relativity. Engineers use stress tensors to predict how bridges and buildings handle forces from every direction. In fluid dynamics, tensors describe how water or air flows, from calm streams to hurricanes. Chemists use tensors to model how molecules respond to electric fields. In medicine, diffusion tensor imaging maps the brain's wiring by tracking water movement. Economists use tensors to analyze complex trade relationships across countries, products, and time. Tensors reveal patterns hidden in multidimensional data, from the cosmos to the cell. Their ability to capture direction and magnitude makes them indispensable. Across science, tensors are the language of complexity. So what's the big idea? Tensors are the ultimate data containers, scalars, vectors, matrices, and beyond. They let us represent anything, a single number, a photo, a video, or even a sentence. Tensors give structure to data, making AI and science possible. They're used by physicists, engineers, neuroscientists, and more. Their power lies in organizing numbers in ways that match the real world's complexity. Next time you use your phone or see AI in action, remember, tensors are working behind the scenes. They're the backbone of modern technology and science. One elegant idea, endless possibilities. Now that's science.